You know, patterns are literally everywhere. The spiral in a seashell, the beat in your favorite song. Our whole world is just built on these repeating rules. Today, we're going to become pattern detectives. We're going to unlock the secret language of sequences and functions. All right, here's the game plan. We're going to start simple, just figuring out the next step in a pattern. Then we'll see how to turn pictures into numbers. And after that, we'll find the master key that can unlock any sequence. From there, we'll meet the amazing function machine and check out 3 different ways to look at the very same rule. Let's dive in. So, first up, let's talk about the most basic way our brains see patterns. Just figuring out what's next by looking at what just happened. This is called the term-to-term rule. Okay, have a look at this. 5, 8, 11, 14. Your brain is probably already firing away, trying to figure out the connection, right? What do you think the next number is? That little mental jump you just did, that's what we call the term-to-term rule. It's basically a simple one-step instruction. You look at the number you're on, you apply the rule, and bam, you've got the next one in line. So, did you figure it out? The rule here is just add 3. Simple as that. 5 plus 3 is 8. 8 plus 3 is 11. It just keeps going. Which means the next term after 14 would be 17. Easy, right? But what if the pattern wasn't just numbers? Okay, so let's switch gears from abstract numbers to something you can actually see, visual patterns. Sometimes watching a sequence grow right in front of your eyes makes the rule just click. And this really gets to the heart of it. Seeing is understanding. When we can visualize how a pattern is growing, all those abstract numbers suddenly make a lot more sense. Check out this growing pattern of triangles. As it gets bigger from one step to the next, can you see what the rule is? How is it actually growing? The process here is pretty straightforward. First, we just turn the pictures into numbers. So we count the triangles, 3, then 5, then 7. And just like that, it's a number sequence again. And the term-to-term rule? Well, it's pretty clear we're just adding 2 triangles each time. So here's the deal. Both of these methods are useful. Visuals are awesome because they're so intuitive. But, can you imagine drawing the 100th pattern? It would take forever. Numbers are a bit more abstract, sure, but they are way, way more efficient. We need something that gives us the best of both worlds. And that leads us perfectly into our next section, the sequence master key. We're about to find a tool that is so powerful, it lets us jump to any spot in a sequence we want instantly. This is called the nth term. Think about it. The add 3 rule is great if you want the 5th term. But what if I asked you for the 100th term? You'd have to sit there and add 3 over and over and over again. There has to be a better way, a shortcut. And here it is, the nth term. This isn't a step-by-step rule, it's a direct formula. You tell it what position you want, say the 100th, and it just calculates the value for that exact spot. It really is a master key. Now, to use this key, we just have to know the lingo. This sequence is the whole list of numbers. A term is just one of those numbers. The position number, which we call n, is its rank, first, second, third, and so on. And that add 3 or add 2 we keep seeing, that's the common difference, which we call d. So this is how it all fits together. The master key formula is dn plus b. We already know d is the common difference, and n is the position we want. Now, b is the slightly tricky part. The easiest way to think of b is as the 0th term, the value that would come right before the first term. So for our 5, 8, 11 sequence, the difference d is 3. To find b, we just go backward from 5. 5 minus 3 is 2. So our formula is 3n plus 2. And now we have it, 3n plus 2. Want to find the 100th term? Just plug in 100 for n. 3 times 100 is 300, plus 2 is 302. See? No more adding over and over. This formula is such a powerful tool. And speaking of powerful tools, your support through like, share, subscriptions helps us continue creating more of these explainers for you. Now, let's see how this key fits into an even bigger picture. All right, on to section 4. Because it turns out our master key formula isn't just some neat trick for sequences. It's actually a perfect example of one of the biggest ideas in all of math. That's right. The nth term rule is a function. And a function is really just a special kind of rule that takes an input and gives you a very specific output. In our sequences, the input is the position number n, and the output is the value of the term itself. Honestly, the best way to picture a function is like a machine. You put a number on one side, the input, which we often call x, the machine does something to it based on a rule, and a new number comes out the other side, the output, or y. And here's the key thing about functions. For every one input you put in, you get exactly one output. The machine is reliable. If you put a 5 in, you'll always get the same thing out. It's not a guessing game. It's a predictable rule. And that brings us to our final section. As it turns out, this idea of a function, this one single rule, can be dressed up in a few different outfits. It's the same core idea, just with a different look. Take a look here. On one side, we've got a function machine with the rule multiply by 3. On the other, we have a table of values for the equation y equals 3x. They look different, but they're describing the exact same relationship. If you pop a 2 into the machine, a 6 comes out. If you look for x equals 2 in the table, y is 6. Same rule, different presentation. So to wrap it all up, we've got 3 great ways to show a function. There's the function machine, which helps us visualize the process. There's a mapping diagram, which literally draws lines connecting each input to its output. And then there's the super efficient algebraic equation, like y equals x plus 5. They're all just telling the same story. We've gone from taking simple baby steps to finding a master key, and we've seen how that key is part of this huge mathematical idea. You now have the tools to decode and predict patterns. So, the final question is for you. Now that you have this master key, what patterns are you gonna unlock?